Hey everyone, you're listening to the Simple Electronics Podcast. I'm your host, Dan, from the Simple Electronics YouTube channel, and this episode is brought to you by Patreons like you. So go to patreon.com/simpleelectronics if you want to support the show. What have I been up to lately? Well, I'm not sure if I talked about this in the previous podcast, but I managed to break 2 of my 3D printers. In fact, I managed to break both of the 3D printers in pursuit of trying to get my version 2 of the Snowspeeder designed and done printed. So let's start from the get-go. Most of my printing is being done lately on my Voron 0.2. That is the Cyborg kit that I got from AliExpress probably about a year ago. I've been loving that printer. I haven't even done the final calibrations and tuning on it. I just did the very basics, and then it's been printing pretty good ever since. I do need to do the calibrations and stuff because that's coming soon, where I want to print some ABS parts. But until then, it's working just fine. Most of the other prints, though, that don't fit in the 120mm by 120mm by 120mm build volume, they're being done on the Elegoo Neptune 4 Max, which I was sent by Elegoo for review. Now, that printer seems to mostly work, but it's not fantastic. So the bed seems to warp a lot during the print. You have to preheat it for like well over a half hour before you can start printing, or else stuff will just lift off the bed, or it'll the bed will buckle and it'll touch the head and it'll get knocked off and whatever happens. However, lately, I've been getting some really odd results. I mean, I've got odd results from the get-go because I think it's just a lack of rigidity on the frame. But this time it was different. And then so I went and I checked my the wheels. So it uses... For the bed, it uses these roller wheels. There's 6 of them, and for the head, there's 4 of them for the print head. And they were all completely worn out, like completely chewed up, as if they were like too tight, adjusted too tight, but they were never too tight. They just wore out. And I checked on Clipper. You can check how long a printer's been in service for, and this one did 300 hours. So that sounds like a lot, 300 hours of printing, but if you think like a lot of the prints that I was printing on it were, 24 hours plus, that's not that many prints. In fact, I think the largest print was 46 hours. So like essentially like 2 days. And I believe that is the version 2 of the Snowspeeder frame, which I've printed twice. Once with junk filament, like just ends of filament, so I can test, the dimensions to see if it'll work. And then once again in the red PLA, which will be the final form of that Snowspeeder. So anyways, it was completely wrecked. And I decided, well, I knew this was coming because the motion system is not great. So I had ordered linear rails for it to replace the X and the Y axes from AliExpress. Now, they weren't super expensive. It was about 180 Canadian dollars or maybe 200 Canadian dollars. So not too bad. But considering the printer didn't cost me anything, Elegoo had sent it to me. And we got to the point in the email chains where Elegoo thought the printer was faulty, so they were going to send me another one. And then they never sent me another one. They just, stopped contacting. So I was like, that's fine. I ordered linear rails for it, so I had them here in stock, and I decided now is the time that I'm going to do the modifications. So I'm going to take it apart, replace the rollers, which were not great from the beginning and got terrible at this point, with linear rails. And during the swap, it seems like the screws that they had sent me, not Elegoo, the aftermarket company that provided the rails that I bought the rails from, instead of using a countersunk like a flathead screw, they sent me a cap screw, or not a cap screw, a button head screw. I think it's button head screw. So it's like a semicircle screw. So it protruded out of the brackets which attached the linear rails to the frame. And that meant that the linear rails had to sit crookedly. They had to sit on that semisphere. And so it just wouldn't work. You couldn't use it at all. So I had to order new screws. And so I thought, okay, since I need to get these parts printed, I do have another printer that is up and running, that is big enough. And that is the Sheenweenie. Most people didn't hear about this because, again, I had a lot of issues with this printer. And the manufacturer just started ghosting me because they just didn't want to deal with the fact that I had a pretty crappy printer. But like with time, I had tuned it and it works okay. It's not fantastic. I had to replace parts on it, but it was working. So I decided to fire it up. I put the files into Cura, sliced it, sent it over to the printer, and the filament wouldn't extrude. Like the filament literally wouldn't come out of the hot end. And then I had to, it has one of those dual gear BMG style extruders. So it has a lot of force on the filament. And it had forced so hard on the filament that it had wound the filament around the gears inside the extruder. And so what's going on, I was thinking. So I took apart the hot end thinking it was a clog, but it turns out that the tube, the PTFE tube, like the Bowden tube, wasn't going into the hot end anymore properly. And there was all sorts of like burnt up stuff in there. And it just, I couldn't get it all apart to clean it out. So basically now it's down 2 printers. And so that was really frustrating. But in that, I managed to order some screws from Amazon. I paid way too much. So these M4 flathead screws came from Amazon in 2 days. So I got the Elegoo Neptune 4 Max back up and running, and it did end up printing my parts. I also changed the nozzle from a 0.4 millimeter, which is kind of silly to have a 0.4 millimeter with no optional nozzles at the time of release of this printer. This is a printer with 420 millimeters by 420 millimeters by 480 millimeter build volume. So absolutely massive machine. And not only is the default nozzle 0.4 millimeter, but there was no replacement nozzles. I got mine from AliExpress. I put a 0.6 millimeter nozzle, but I'm starting to regret it. I probably should have put a 0.8 millimeter nozzle because, again, it's a massive build volume. So you want like a really big nozzle. So I redid everything, put the linear rails on, changed the nozzle. I updated the firmware for the LCD, and what else did I do? Retrammed the bed. Oh yeah, and I replaced the bed springs with silicone spacers instead of springs. And at the moment, the printer is running better than I've ever had it, which is pretty nice. It still has bed adhesion problems because that bed does flex and warp quite a bit during printing. Like it just seems to bow to the point where your nozzle starts like hitting the inside of the print as it does its travels. And also, if you don't have a very, very large surface, touching the bed, you get really poor adhesion. And even so, like PLA will still lift the corners. So overall, it wasn't a super great experience, but it is working now. So that's nice. And I'll probably end up making a video warning people if they need a machine that can do such a large volume and they don't have a lot of money, the 4 Max is a good idea. But otherwise, large form factor, I don't know what else you would get because it's really not it's not an expensive machine. That's the great part. But if you buy it expecting, no problems, then you're probably going to be disappointed. For the other machine though, the Sheenweenie, so that's a weird one because the Sheenweenie doesn't appear anywhere. You can Google it, SIENWINY. And I think it's called the Panther. I forget now what it's called. It's not written anywhere. That machine had really good bones. Like the frame was good at the time. It was running, decent firmware, had double Z-axis lead screws with, I believe it had a synchronizing belt on top. Had a big bed, 330 mil by 330 mil. I think the Z height was 400 mil. So it was a good machine on paper. It had a dual gear extruder BMG. It had a all metal hot end. So everything looked good on paper. BL Touch as well. Everything out of the box. But the software implementation just wasn't great. And also, the quality assurance, the QA and QC was not good because my extruder stripped gears. It lost the set screw a couple times. Like a whole bunch of things happened where it just wasn't a good out-of-box experience. But now, because the hot end was clogged, or like the hot end throat was clogged, I was kind of stuck. And let me explain to you why. So most hot ends mount from the very top of the aluminum heatsink. And the way it mounts is kind of standard. You've got like the V6 style, which has like a little bit of a throat, like a cylindrical throat. Or you've got like the CR10, Creality style, which have like the 2 mounting bolts. And then you have a couple of variations on those, but it's all kind of standard. But on this Shinwini, which again, you can't look it up for parts. You can't just, look for parts for my Shinwini. It doesn't exist anymore. It's a lot harder. So it has a custom aluminum block to cool the hot end. And that also mounts it into like the cage where the hot end sits. And it mounts it strangely. There's like 4 mounting screws on the very top and 4 mounting screws through the body itself, which also holds a cooling fan. So it's like very oddly shaped. And it's like a rectangle, but the filament path is not in the center of the rectangle. So I had to take this thing apart. And also I didn't want to mess with the firmware. So I went through all my hot ends that I have here because, I had ambitions of building stuff myself. And I found like a whole bunch of hot ends that are, workable, but I would have to make custom mounts to fit them into that enclosure. And when you make custom mounts, then the vent, like the fan, doesn't line up with the vent in the frame. So it was really not a good situation. However, by tearing it apart, the hot end that had failed, I've noticed that a lot of the parts are quite similar to the E3D Volcano. So it has a custom, cooling section, custom heatsink. However, the throat that goes in, that links to the hot end, to the heat block, that was very much like an E3D Volcano. So I took some measurements and I ordered one. Let me pull up here which part actually fit. Actually, I probably won't even know because I got a whole bunch of parts at the same time. So if I just go tracking, package delivered, received. Okay, so this one here. Yeah, I found a CR10 V3 or the Ender 3 V2 throat seems to fit exactly the right size I need in the heatsink block. And then the hot end, the heater block, that is from an E3D Volcano. And the silicone cover is also from an E3D Volcano. The nozzle seems to be from an E3D Volcano as well. And then the heater cartridge and the thermistor all seem to be from an E3D Volcano. So I bought aftermarket parts. I bought a little bit of an upgrade. Instead of using the aluminum heat block, I ordered a copper heat block with which is plated. I'm going to put the nozzle in when it comes in, and I'm going to put it all together, and I'm going to see if it works with the old heater cartridge and the old sort of thermistor, so I don't have to mess with firmware. If it does work, great. I'll keep printing with this printer for a little bit. If it doesn't work, however, I believe that I didn't buy all these things for nothing, because the printer has really good bones. It's a really good, it's a decent quality machine. It just, lacks in, firmware and control and all these things. If it doesn't work, I'm just going to put one of the controller boards that I have laying around here into it, and then I'll just transplant my own internals. So, the parts that I'm buying won't be for nothing, because I think the frame is good. I think the implementation is good. The extruder is good, especially I just replaced the extruder. The hot end is going to be brand new. And so I think if it doesn't work, I'm just going to take all the internals out. Might upgrade the wiring, because the heated bed wiring is a little bit in the inexpensive side. A little thin for my liking. But upgrade it all and put my own, internals in, because I haven't, I have these motherboards, these 3D printer logic boards sitting around from my custom projects that I was working on. So I might as well put it to work. And so I think that's going to be a pretty cool video, taking like an unknown 3D printer, something that doesn't really have any documentation, ripping the guts out and putting in my own electronics. So I think that's going to be pretty fun. But hopefully it does just work like this, so I can get my projects done for now. And then when I get the chance, I'll switch it over. So what else have I been up to? Well, a lot of live streaming. In fact, I think I have 8 to 10 videos in my editing queue so far that were filmed on live streams. If you're interested in that, it's youtube.com/SE streams. Nothing to do with Sweden, just Simple Electronics Streams, so SE streams. Well, I have been driving to Cornwall, Ontario from Ottawa, Ontario. I did that last weekend on Saturday for a course in EVs. So this is like a EV upskilling thing that the government is putting on. So essentially, if you're a mechanic, you can take additional skills trainings to be more comfortable or more qualified, maybe, to work on EVs. Here in Canada, there's no specific EV licensing. So as soon as you have your technician's license, like I have, you can work on whatever in the trade, except for truck and coach, the heavy stuff, that's a separate license. So I was lucky. I did most of my career in a dealership, so I had a little bit more access to hybrids back then, less so EVs. But now with EVs, there's new dangers, I suppose. And so you can take these, upskill courses to make sure that you're well-versed in, at least EV safety and how it works, etc. Now, the first course was mostly about safety. So a lot of the stuff that we went over in class and, in the workshop over there was stuff that I already knew. It was stuff that I knew, whether it be from my career, from working around EVs in my current day job, or stuff that I had looked up, as a professor to teach my little portions of the curriculum to my students. But I figured I would go over a couple of the things that I found really interesting, some of which I already knew, but some of the stuff is brand new to me. That has to do more with electronics. So EVs and electronics have a big overlap. Like everything you can think of, like if you're thinking of a brushless motor driver for, a brushless motor. So, that's usually it's a series of MOSFETs. You'll have 3 NMOS and 3 the other ones, the positive MOSFETs and the negative MOSFETs. When you have like an H-bridge driver, but a 6-way for a brushless motor. Those things exist in an EV as well. However, it is scaled up big time. So just a little bit of background. The program that I went through, they had a Hyundai Kona EV. So that is a 400 volt class EV. There's typically two classes, 400 volt and 800 volt. If you're buying a brand new car today, unless money is a big concern to you, but if you're buying a brand new car, it's a little bit less a concern either way. But unless you're really concerned about money, you probably want an 800 volt EV. We'll get into the reasons why a little bit later. But they have a Hyundai Kona EV, and they have a Tesla Model 3. Not a big fan of Teslas. In the last couple of years, Mr. Elon's been showing us his true side, and it's been getting worse and worse. And now he revealed himself, to be his truer side. His truest side has come out. And so I wouldn't recommend buying a Tesla, but there are people who own them and they need them fixed. Especially, it's weird. They're not really reliable for not having that many moving parts. But anyways, I digress. Also a 400 volt EV. But what makes this program cool, because I've worked on EVs quite a bit now, is that they went and they bought duplicates of a lot of the parts in each EV for the program. And not only did they buy duplicates of things like the wiring and stuff like that, but they bought an extra battery for both vehicles, and they tore them apart. And so we get to see on the inside of those battery boxes, it's incredible. It's not something you see every day. Typically, if a customer comes to you with a battery needing replacement, they are not serviceable. They are sold as one unit. But the really cool thing about this course is they open up the batteries and you get to see on the inside. And in fact, they're a lot more serviceable than you may think. It's just, I guess, not economically viable, or maybe too dangerous, or I don't know what the big deal is. Probably not economically viable and also dangerous. But I think if you're patient and very careful and take the specific precautions, I think EVs can be repaired, in fact, more easily than a typical gas vehicle. For example, the Kona EV had 5 distinct packs, like banks of batteries. Now, I'm pretty sure they're just in series parallel banks, like they're basically like cell packs, and there's 5 of them equaling up about 360 some volts. That's why it's called a 400 volt class EV. And there's always a service connector on EVs that you disconnect. And my original thought was that it would disconnect either the positive or the negative or both of the battery to its external connections. However, that's not the case at all. It actually splits, there's the bank of 5 batteries, the battery banks. It splits 2 off from the other 3. And since the banks of 5 are in series with each other, a split anywhere will cause no current to flow. You can't have a positive or a negative anymore. And so when you pull this service connector out, you're cutting the battery in 2 essentially, and you don't have positive and negative at the output anymore, because the positive of one bank finishes at the service plug, and then the negative of the other bank finishes at the out plug. Pretty interesting when you think about it. So if you could stretch your arm from the positive output over to the service plug, which is too far, you can't do it. It's physically impossible. And I guess you can run wires. You would only have access to half the voltage of the pack, or 2/5 or 3/5, depending on which side you're touching. I think that's really cool, really interesting how they do that. And on top of that, we went through the disconnect procedures depending on the manufacturer. Every manufacturer has their own disconnect procedures, but then we checked for presence of voltage. There's no voltage there. But I just found that really interesting how you divide the pack in two. Also, just because the pack is live doesn't mean that there's output at the output terminals. Like, if you think a 12-volt lead acid battery, if if you charge it up, there's going to be 12 volts on the output no matter what. Well, not so on an EV battery. The EV battery has two contactors, one on the positive pole and one on the negative pole, that allows current to flow out. So there's actually two contactors. They break both the positive and the negative. And in cars, typically the ground, the negative, is also the earth. It's the same connection. The whole chassis of the car is at a negative potential. Your 12-volt battery has a cable going directly from the negative terminal to the chassis, the metal of the car. But on an EV, the high voltage is completely isolated. It does not have any sort of protective earth or, negative connection or chassis connection, none of that. 100% isolated. So it's really cool to know that there's a positive and a negative contactor that will completely shut off power to the outside of the battery. And a contactor, in case you're wondering, think of it as a relay. So a relay is a switch that is activated by an electromagnetic coil. The difference between a relay and a contactor is typically a contactor is for higher currents. So if you think the motor in that thing, I believe, is 150 kilowatts, 150,000 watts. And so that current has to come from the battery. So it has to pass through both contactors. Another really cool thing is that when you have like a solar array at home, or a solar panel and a battery, and then you want to plug like an inverter on it. You want to plug something so that you can, plug in your blender when you're camping or whatever. They say you're not supposed to connect your inverter directly to the 12-volt battery, because what happens is your inverter has giant capacitors inside. And when you plug in your battery, that does it just wants to pull as much current as possible, because the resistance of a empty capacitor is effectively zero. It's effectively a short circuit. So especially when you have lithium batteries, which have an incredibly low internal resistance, you don't want that inrush of current. And it's the exact same thing on these EV batteries. They have a contactor, a third one, that is different from the positive and the negative one, which has a pre-charge resistor. So this is a contactor that turns on first through a resistor to charge up the capacitors in the motor drive and the motor inverter and all that stuff before the positive and negative contactors can turn on. So it'll actually slowly charge. I know I say slowly, I mean in a matter of a second or two, charge up those capacitors so that you're not pulling, 10,000 amps from the vehicle battery, which is really cool. And I have pictures of it's sitting there in the battery, and it's just a ceramic resistor. So we see those resistors, you can buy them on AliExpress. The contactors are just bolted into the battery box. They have a BMS, very similar as to when you're building your own lithium, batteries for solar. You need to connect a BMS to check the charge, the charge level on every single cell. Well, they have the same thing. They have a BMS, and in fact, in the Kona, it's replaceable. There's a little door on the EV battery pack where you can actually open it up and pull out the BMS. It's like very much electronic-y, right? And if you're wondering where this battery pack is, first of all, the battery pack weighs several hundred pounds. It's very heavy, and typically it is mounted underneath the floor of the car. So like it's just hanging about, under the car. And typically it is completely weather sealed. So in the case of the Kona, the two halves of the box itself is aluminum. And then the two halves, the aluminum, top and bottom, they're linked together by a whole bunch of bolts. And between the two halves is a rubber gasket. So it's really something that you can take apart and put back together and expect it to still be in service after. The Tesla, however, not so much. The Tesla is kind of gooped together. First of all, the top cover is very weak. It's very thin. And it is like glued together. So you have to pry it apart and you damage the top cover. And apparently, if you do take off the top cover, you are supposed to replace it. Although I believe I've seen videos from YouTuber Rich Rebuilds where he just, put it back together. But yeah, apparently you're not supposed to. Another thing to keep in mind is that these batteries are filled with coolant. They are not passively cooled. I mean, some of the cooling definitely, because the batteries sit underneath the vehicle and they're in an aluminum case, some of the cooling is going to come from the air rushing over the aluminum case, but they are actively cooled. So there are coolant channels going underneath. In the case of the Kona, there's like these cooling plates that go underneath the cell packs. What's scary to me, though, is that there's like kind of two input ports, or an input and an output port for the coolant. And then it's plumbed through like hard plastic line. And if you're a car person, or if you just happen to have the misfortune of owning a GM, the hard plastic line strongly resembles the hard plastic line that General Motors uses in their evap systems, which is prone to cracking and breaking. They also use quick disconnects. So it's a type of pipe disconnect that you can just squeeze with your thumb and pull apart as if it was made to be serviceable. But again, they don't sell individual parts. They want you to service it as a unit. They also have temperature sensors, which talk to the engine computer, or the battery computer, probably. They have coolant temperature sensors, air temperature sensors, and a liquid ingress sensor. So if ever the seals would fail, or if there's a coolant leak, it would then not allow the contactors to activate. So again, very much stuff that we could verify on Arduino, right? Very much stuff that we could use a microcontroller and process ourselves. So that's interesting. But the scary part, though, is that I've made quite a bit of money in my career replacing temperature sensors that have failed or corroded or whatever. So maybe not the best thing when you're talking about a whole unit, a battery unit sold as one unit. Also interesting is that nothing is like welded or glued or sort of like permanently fastened. It's all like it's all bolted together, which is really cool. I've got pictures of all this too, which I find it's interesting. Also, there's no wires inside. Well, there's wires for the BMS, but the cells are not wired to each other using stranded wire, not even solid wire. They're using bus bars. So it's like literally like a rectangular cross section of copper, and it's coated in orange insulation material. But that's what's the connection between the cells. So there's no flex there. So all the on-road vibrations, I feel like, will eventually fatigue the metal. Now, the instructor has told me that there was a lot of like damping foam, insulation foam, and like support structure inside the battery that were removed so that we can see inside a lot better. We can see the components better. But it kind of scares me a little bit that there's not that flexibility. I think I would like a stranded copper wire and it to be affixed onto a surface so that for the most part, it won't move at all. But if there is some movement, you're not fatiguing as much as a bus bar. Maybe there's an engineering reason for the bus bar. I'm not sure, but I found that interesting. The other super interesting part is dealing with the charging. Now, we didn't go into a lot of details. In fact, this was a very introductory section of the course. This week, we are supposed to be looking at temperature management on Saturday and engine drive and control, or motor drive and control on Sunday. But again, this is all things that I've picked up during the course when I was there on Saturday. So when you charge an electric car, first and foremost, you have a couple of levels. So there's level 1, level 2, and level 3 plus. Not 100% sure after level 2. But level 1 is you plug in a regular 110 volt outlet, maximum 15, 20 amps, whatever it may be. So that is the lowest charge, the slowest charge. And for a lot of people doing daily commutes, at least here in Ottawa, if you plug in your car when you get home at level 1, it'll be fully charged by the time you need to leave again tomorrow. That's for a daily commute. Most people's commute is under 80 kilometers, under 60 kilometers, I should say, both directions. So slow charge is perfectly fine. Level 2 is when you use a 220 or 240 volt outlet. That's something, your water heater or your dryer or a welder, your pool, whatever it would be plugged into. That is a level 2 charge because you get a lot more voltage, a lot more current. I believe it's again a 20 amp, but at 240 volts. So quite a bit more. And that is if if your battery is, at 20%, when you get home, you plug that in when you get home, it'll be full by the next morning, most likely. Depends on your EV. Some EVs have really big batteries, so it might take a little bit longer. But yeah, there's that. Then you have like high-speed charging, what Tesla would call the supercharging. And typically this is not what you do at home. It's a DC fast charge. So the DC fast charge is like when you see those 180 kilowatt chargers or 200 kilowatt chargers or whatever. That's when you see advertised your EV can go from 20% to 80% in under 15 minutes when you're on the road, when you're doing a road trip. That would use DC charging. So let's start from the get-go with your AC charging. So when you plug in your AC charger, your charger will communicate with the EV to tell it how big of a cable it has, how big of a charge cable, like what's the gauge of the wire of the charge cable. So that's how much it'll be able to take from your plug. Don't forget your plug in your wall is not regulated, right? If you short it, you're going to get full current for, until you blow the breaker. And so it's actually your car that controls the charge rate for AC. And so typically you can set your charger. You can tell your charger, don't charge more than this many amps. But what will happen is your charger will just tell the car, don't pull more than this amount of amps. It's really your car that does the charging. So your battery is DC and your input is AC. And so the EV on board has a AC to DC converter as well as a boost converter. So what it'll do is it'll take the 110 volts AC, rectify it to DC, step it up to the higher than the max voltage of your battery, and then PWM it to charge your battery. So you actually have a AC to DC converter inside of the vehicle. On some cars, they're reversible. So you can do V2L. So you can actually have your DC go through the same inverter and output AC, pure sine wave AC to power your house. Use it as a generator. Pretty interesting stuff. Now, the other thing is the DC high-speed charge. When you plug that in and your charger is able to do it, it'll open the contactors or close the contactors, and it will have direct access to the full pack voltage. It bypasses all the electronics in your car and allows the charger to interface directly with your battery. That means the charge station, because it still gets AC power from somewhere, the substation or whatever. So the charger will have a massive, step-up converter and a massive AC to DC converter, and it'll actually charge with DC. But again, it is controlling. At DC, I believe it just, pumps the amount of current that it's allowed to pump. So that's completely fine because you're just charging the banks directly. So it's really controlled by the charge point. But in AC, it's controlled by your vehicle. So very different. And how is the communications done? Very simply. It's actually you can go look it up on Wikipedia. It's called the hang on, I want to make sure this is right. J1772, I think. Yeah, SAE J1772 is the charge way to do it. So basically, it has a couple of signaling pins. I think it's one. I think it's just one. I think it's literally one signal. It's like a 1 kilohertz wave with an on duration, and that on duration is essentially what dictates how much current can flow through the cables. So why earlier did I say that you want an 800 volt EV and not a 400 volt EV? Well, if you go to a charger that is capable of, let's say, 100 kilowatts, right? 100,000 watts. If you have an 800 volt EV, so we go 1 kilowatt, so 100,000 watts, doing the math live here, and you divide that by 800 volts, that is 125 amps. So in order to get 100 kilowatts, you need a charge cable, like between the charger and the car, that is able to handle 125 amps of current. Okay? So that is for an 800 volt vehicle. So if this charger is 100 kilowatts and it has a cable rated to 125 amps, you get the whole 100 kilowatts. That exact same charger, though, if it is capable of a 100 kilowatt charge, but only has a 125 amp cable, if you have a 400 volt EV, you're not going to get the whole 125. You're not going to get the whole 100 kilowatts. You will get half of that. You'll get 50 kilowatts. You'll be limited to 50 kilowatts because no matter what, this charger can only output 125 amps before it overheats. So the charger knows that it can only output 125 amps. And so no matter what your battery voltage is, it only will output 125 amps maximum. So at the exact same charger, it'll take you in the 400 volt EV double the amount of time to charge. So something like a Hyundai Kona EV, at this charger, let's say it would take 40 minutes to charge from 20 to 80%. Well, your Ioniq 5, which has an 800 volt system, it would take 20 minutes. It would take half. And so that is the big deal with the 800 volt EVs. But it's not just that. Don't forget that for the same amount of output power, like motor, We're talking about like horsepower, more like kilowatts, but we're talking horsepower. For the same amount of output, you're going to have to pull twice as much current on the 400 volt EV as the 800 volt EV. That means all your wires have to be bigger. Your bus bars have to be bigger. Your batteries need to be able to discharge twice as much current, right? So your pouch cells have to be engineered better. So essentially, and mind you, the difference, I think here in Canada right now, you get a Ioniq 5 with a 800 volt system for like $55,000, and the Kona EV is $45,000. So yes, it is more expensive. However, I think if you're planning on ever going on long trips with it or whatever, or if you're the type of person that gets range anxiety, you'd probably be better off with the 800 volt Ioniq. Plus, it's not just apples to apples. The Ioniq is bigger. It's got, better interior, etc., etc. So it's not that simple, but definitely consider an 800 volt EV. In fact, a friend of the show, Aging Wheels, and what's his second channel now? Well, I'll link it in the description anyways. He did twice a road trip with a 400 volt EV and a 800 volt EV, and he just redid it last year again. So he did it last year and then like 2 years ago, and the difference is pretty big. Like the 800 volt vehicles can charge a lot faster. Now, as far as the safety aspect for EVs, it's pretty interesting. There is not too much for the end consumer to worry about. It's more like the people who are working on these things. There's little things like, obviously, if you get into a collision and it pierces through the battery box, it is possible that it catches on fire, just like a gasoline car having the fuel tank punctured. I mean, samesies, right? Although they are a lot harder to put out, the fires are. And if you don't have a Tesla, you're probably likely to survive. If you do have a Tesla, for some reason, in an emergency, it locks the doors on you. Not a great thing if you're trying to get out. However, for the people working on them, there is not a lot of consideration put into the people who work on it, specifically for DC. It sort of happens that when you cross a certain voltage threshold, probably above 200 volts or so, which is what EVs, they all run above 200 volts, you start to get into the best practices for like electricians, but like not just electricians, but like line workers, industrial electricians or people who work on transmission lines and stuff like that. So there's not a lot of very specific things for EVs that aren't covered in other industries. So what's interesting is you have these big, heavy rubber gloves. They're insulated. They feel like silicone, but I think they might be natural rubber. But you have to pull these out of a bag, and then you have to inflate them, and then you have to squeeze them down to make sure there's no air leaks in them. They're very fragile, but they're very insulative, usually, above 1,000 volts. However, they're very fragile, right? So you can't work on like metal objects. You can't work on things like a battery case or whatever it may be. So you need to put leather gloves on top of these rubber gloves. And these leather gloves, they can't go the full length of the rubber gloves because leather isn't as insulative as the rubber. So the leather gloves just go right below your, until right below your palm, and your rubber gloves, they go another inch or two or a little bit more past that to make sure you're insulated. So now you have two pairs of gloves on, one on top of the other. And now you're trying to work with tools, right? Metal tools around, hundreds of DC volts. So when I was reading the literature and teaching my students that, you should have a set of insulated tools, not every manufacturer says you must use them, but I mean, it's just at that point, it's just kind of like high voltage safety set of tools covered in rubber or plastic or whatever. I didn't really put two and two together that when you're wearing two thick pairs of gloves, one on top of the other, you are now clumsy. You now do not have the dexterity that you're used to because you are literally covered, every surface of you with like 6 or 7 millimeters of extra thickness to work through. So you become more clumsy and you're more prone to drop things. So that makes a lot more sense to me. Also, the high voltage wiring, in case you're wondering, if you work on, if you own or have, or help a friend with a hybrid or an EV, typically all of the high voltage wire is covered in orange insulation. So typically that's the outermost shell. It'll be like orange tape, and then there'll be like an orange plastic loom, and on the inside will be your orange insulated cable, and then on the inside will be copper. So there's quite of a distance there, but just on the outside of the copper's insulation, there'll also be a shield on top, like a wire mesh on top. And that is not for EMI protection, as you might think. That's actually for safety. So if any voltage is generated on that wire, or if it's ever cut, if it's not continuous, the BCM will know and it'll shut off the contactors. I was told that most of the failure modes in EVs is not the motor or the motor driver or the battery, but the safety measures put around these things. The safety measures are meant to fail before anything can go wrong. So like if something goes short, well, the contactor will be, will sacrifice itself. Yes, it'll sort of ruin your battery. In that case, you're going to need a battery pack. But I think once a whole bunch of salvage yards have EV parts, then we'll be able to take out contactors. And I believe that the aftermarket world will start creating parts, replacement parts for these things. I keep telling my students that you don't have to worry about your job being replaced because EVs are getting simpler. You just need to skill up, and then you'll be the one to repair the new generation of vehicles. And then you'll never be out of work. And I think that's pretty true. So I hope you enjoyed that little bit of a tour around EVs. I'm going to be learning more, obviously, in the upcoming weeks. And if you guys don't want me to talk about EVs anymore, let me know in the description below, or in the comments below, I should say. And yeah, I'll save that for another YouTube channel. But I did think there's a lot of overlap with electronics and EVs, and especially things like hacking. Like I feel like if you can hack your way to, getting access to the high voltage battery, there's some pretty cool things that we'll be able to do. Not for the faint of heart, obviously extremely dangerous. But then again, people smoke their cigarettes while replacing their fuel tanks in their cars. I've seen it being done. So it's just it's a matter of managing the risk, essentially. So yeah. So what else am I doing? Well, what's upcoming is mostly live streams. Now I have to edit a whole bunch of videos. I have a bunch in the queue, but I feel like this sort of reinvigoration to stream and to make videos. So I have a bunch of stuff upcoming. And one of the concepts that I've been thinking of is that my sort of equipment stack, mostly provided by Unity at this point, above my workbench is the test gear that I used the most. I don't have an oscilloscope as part of that test setup. I have 3 oscilloscopes here. In fact, I have a Keysight, I have a Rigol, and I have a Unity as in terms of full size oscilloscopes. I have a couple of USB scopes as well. But I don't have one in my equipment stack. And so I was thinking of making a little bit of a tongue-in-cheek, The Bachelor type thing, where I take my 3 oscilloscopes out, I run them through a series of tests, and at the end, I'm going to have to pick one of the scopes that I have here to quote unquote give a rose to basically choose to be put up on the equipment shelf where I'm going to use it the most, to be the one that's plugged in permanently, the one I'm going to use on the daily, instead of just going back, grabbing whichever oscilloscope that I see, the first one, and bringing it to the workbench and using it. It'll be permanently set up. So I kind of want to find an interesting way to film that. I've got a whole bunch of other ideas for videos. Let me see if I can pull up my Google Sheets fast enough for this to not, hold up the process too much as I'm speaking and making up words in order to make this go faster. Video ideas. Here we go. Oh yeah, I made some lithophanes for Christmas for the family. And so I did design my own custom holders for lights and stuff. So I do want to make a video on lithophanes and my light holders and stuff. I need to edit the Fluke videos. So those of you who don't know, I bought 4 cheap Fluke multimeters and I put them through their paces. I have more videos to film, but I also have to put out the Fluke video to start with. Another one is I want to test different diodes, what their forward voltage drop is at different currents. So yeah, essentially I've got a lot of stuff to do. So if you want to see me film these kinds of videos, I want you to go over to youtube.com/SEstreams, SESTREAMS, and join me on my live streams. I typically let people know on Blue Sky, roughly 12 to 24 hours before I go live. So follow me on Blue Sky if you want to be updated on when the next stream is. Well, I guess I'm going to try to get this edited. It is now 11:30 on the day before this is supposed to go live. So I need to get this edited. I want to thank you all for listening to the podcast. And don't forget, podcasts like this are funded by patrons like you. Go to patreon.com/simpleelectronics if you want to support the show. Thanks for listening. I'll catch you in the next one.